Okay, your EOC prep involving multiple representations for Wednesday and Thursday. The first little part here has you solving for y, which means we're going to put it in the slope-intercept form. Now, on all three of these, this is going to require that you get the y by itself. And it's going to ask you to either add or subtract away an x term at the very beginning. So you can see as I subtract this 3x away because initially it was positive. And then I'm also in the habit of putting the x terms first. So I end up with y equals negative 3x plus 4. That one is solved for y. For the second one, I'll end up adding away the 3x because initially it was negative. And I'll have 2y equals 3x plus 4. Now I can't leave it like that because it's not solved for y. But I can divide away this 2. A common mistake that people make is that they don't divide each one of the terms on the right by the 2. In other words, it's the 3 divided by 2 and the 4 divided by 2. So it's like you have two division problems there. Well, the 3 over 2 is a fraction. It can't be reduced, so we'll just leave it as 3 halves x. The 4 over 2 can be reduced. It's a 2, and we have y equals 3 halves x plus 2. Okay, last one. Here we'll subtract away the 3x. And we have negative 5y equals negative 3x plus 15. Common mistake here, too, is not bringing down that negative with the 5y, because that 5y is being subtracted. And why that matters is when we do our division here, this step requires us to divide with the negative as well. So y equals, let's check our fractions here. That first one's going to be a positive 3 over 5x. And the second one's going to be a negative 3. Okay. Now the advantage of having these equations in slope-intercept form is it basically makes them much easier to graph. Now as you can look at your next little set of problems here, you're going to be given a 4 corners or multiple representations. You're going to be given one of them, and I want you to be able to fill in the other 3 by any path that you choose. Now as we go through these examples, obviously we'll choose my path. Okay, so in this one you're given an equation. And of course it's not in standard form, or sorry, it is in standard form. We want to put it in the slope-intercept form. So let's begin to solve for y. Here I'll subtract away the 2x. I'll get negative 4y is equal to negative 2x plus 8. I divide away that negative 4. And I will get y is equal to, so let's look at our fractions here. Positive 2 over 4, well, that's just 1 half x. And then minus 2. Okay, so y equals 1 half x minus 2. Now from here you get a choice. You could either graph this, because now it's in slope-intercept form, so you can go directly below. Or if you wanted to go to your calculator to your y equals, you could put this into there and then just check the table. I'm going to go ahead and go to the graph. In the slope-intercept form, remember that you have a starting point. In this case, it's negative 2. So I go to my y-axis, and I will put down that negative 2. And then the slope here, 1 over 2, that tells me to go up 1, right 2. So from my starting point of negative 2, I'll do just that. Up 1, right 2. Up 1, right 2, and so forth. It also means I could go down 2, left 2. Get a good little pattern going here. And then take a straight edge and graph my line. Okay. Now from there, I can either go to the verbal description or the table. I'm going to go with the verbal description. Basically, I'll just talk about what we just did with our graph. The graph of the function contains the starting point 0, negative 2. All right, so we're going to start at 0, negative 2. That's exactly where we made our first dot. And when the value of x increases by 2, in other words, when we go right by 2, the value of y increases by 1 unit. In other words, we go up by 1. Okay? All right, let's think about the table. If we did throw this in the calculator, we could produce a table, but we could also just get them off the graph. When x is equal to negative 4, so when x is right here, that means that y has to be at negative 4 as well. When y is at negative 2, which is right here, well, that's our starting point. That means x has to be equal to 0. When x is 2, that means that y has to be equal to negative 1. And when y is 1, that means that x has to be equal to 6. Okay? Let's go to the next example. Here we're given a graph. From that graph, you should be able to look at that and generate a starting point and a rate of change. You could also go here and plot the points on the table. We'll get to that. Let's do the equation first. Okay, so I have y equals mx plus b. And my starting point here is 1. So that means I'm going to replace that b with 1. Okay? Then I take a look at my slope. As I go from one point to the next, let's say from the blue to the red here, I would go down 3 and right 1. That gives me a slope of negative 3 over 1. Okay. Fill in the rest here, and I've got my equation. Okay? Let's go to our verbal description. Basically what the graph does is it starts at a starting point of 1, so 0, 1. And you can look at your slope here, and it says, okay, as the value of x increases by 1 unit, that means the value of y, well, since this is negative, is going to decrease by 3 units. So it goes down. It decreases by 3 units. Okay? Let's fill in our table. When y is 4, that means that x has to be negative 1. When x is 0, well, that means the starting point here is going to be 1. When y is negative 2, that means that x has to be 1. And then when x is 5, whoa, that means that y has to be something very negative. Okay, so how do we figure this out? Well, from this, I would go back to the equation. And if y equals negative 3x plus 1, and they gave me a value of x that's 5, well, I'll plug in that 5 and see what I got. Okay, a little bit of order of operations here. Negative 3 times 5 is negative 15. Tack on your 1, little tug of war, the 15 wins by negative 14. Okay, so where the graph let us down, the equation was able to pick us up. Okay, last one. Let's say they give us a table. Okay, from the table, I would either go straight to the graph, or I would come up with the equation, and I'll show you both paths and see which one you prefer. Okay, let's do the equation first. To get the equation, I'll need a slope and a y-intercept. Okay, well, the slope is just a fraction. It's your change in y over change in x. So as you work your way down the table, from negative 6 to 0, that's a change in 6. From negative 3 to 0, that's a change in 3, excuse me. Well, that gives me a fraction of 6 over 3, or 2. Now, you can also write that as 2 over 1. With the b, we're looking for where this line is going to cross the where it's going to cross the y-axis, which means that your value of x has to be 0. Well, that's looking at this point right here. It's going to cross through the origin, so the starting point is 0. So as I go back over to my equation, I know that my equation is y equals 2x plus 0, and I got that all from the table. Well, let's say that you don't feel comfortable doing that. Well, you can go to the graph, kind of an intermediary step. Let's plot these points. Negative 3, negative 6, 0, 0, 1, 2, and 2, 4. Get yourself a good little line going. Okay. You can see that this guy does cross through the origin here. So there b is equal to 0. You can also see that as you do your rise over run, it goes up 2 and then right 1. Well, that gives you a slope of 2 over 1. So you can come up and write your equation, and lo and behold, it's the same 1. Okay? All right, so from here, let's finish up with our verbal. We got a starting point of 0. It goes to the origin. As the value of x increases by 1, well, that means the value of y, this is a positive slope, it's going to increase. So it increases by 2 units. Okay. When you guys roll in on Wednesday and or Thursday, be ready to work with multiple representations. Thank you very much. Look forward to seeing you.